We're here in a nice sunny Barcelona at Mobile World Congress 2012. This is the annual meeting place of the mobile industry. Everybody involved in the mobile industry congregates here once a year. One of the really exciting issues is that of the rollout of LTE, the new 4G technology. We've not only been able to see new products, but also to scratch beneath the surface and see some of the issues that are going on. One of those that was certainly going to be known about beforehand was that of battery life. And we've seen some of the the handset developers talk about that. Nokia have released several new phones, and one of those is an LTE phone, and they've put with that an 1800 milliamp hour battery. Other developers have been less open with the issue, but we've still known that they've got issues with battery life. So let's go inside to some of the halls and see some of the technologies, some of the things that are new in the industry this year. One of the things that we're seeing is a lot of test equipment is being used for the development of LTE and these other new technologies. We're here on one of the stands of one of the manufacturers of the test equipment. They can provide both equipment for testing the user equipment, the UE, and also the base stations as well. So they're able to provide both ends of the test chain. But we've seen quite a bit of other interesting equipment in terms of batteries as well. And in a minute, we'll be speaking to somebody who's been involved with the test equipment that can test battery life and see how that performs under different conditions of the user equipment, under different conditions of data download and various other things. And again, here we are on the Aeroflex stand, talking to Michael Vavrek, and he is going to tell us a little bit about the battery testing system that they have to check the battery draw on LTE devices. Michael.
Yes, so what we have here is our Aeroflex 9300 product. This is just a prototype. We're hoping to launch the official product later this year. What our device does is an instrument to measure both current and temperature on UE device. So as you see here, we have some plots, and this works also with our 7100 product. So what we're able to do is generate video in this example over the 7100 over an LTE connection to the phone. And then using our 9300 instrumentation, we're able to measure the different states that the UE is in. So we can plot and measure the current when we're in airplane mode. We can do it for an LTE connection. We can do it when we're playing video over an LTE connection and be able to capture all that in our current graph using our product. Again, we're also able to use thermal measurements, so we can trace and track thermal, whether it be ambient or near power sources on the UE device.
Michael, thank you very much indeed. Thank you. Well, with battery life being a real issue for LTE 4G handsets, one of the things that's got to be done is to make the handsets more efficient so that the battery life can be extended. And one of the technologies that's being used for this is a technology called envelope tracking. And we're here on the Nujira stand, and I'm talking to Jeremy Hendy. Jeremy, can you tell us a little bit about this technology?
Sure. So envelope tracking is a power supply technology that's being used to optimize the efficiency of RF power amplifiers, and it works by dynamically modulating the supply to the RF PA along with the waveform you're transmitting. So it's essentially a very, very high bandwidth power supply technology.
And what sort of efficiency improvements are you seeing in that?
So we're seeing the efficiency of the RF power amplifier go from about 30% up to about 60%. So that really corresponds to about a 30% reduction in power consumption in an LTE terminal, which in watt terms is about half a watt at maximum power. So quite a significant.
That's great. And is this going to be more see more use with the LTE using more and more bands all the time? That's also creating issues for the handset designers.
That's right. So there's currently 18 frequency bands in use worldwide for mobile comms, and another 3 or 4 planned to be rolled out this year. So increasingly the handset vendors are having to put in multi-mode broadband PAs to cover that. But the efficiency of those drops even further, so you may be down to 25%. So this technology really helps the handset designers to broadband multi-mode PAs covering 20 bands.
Jeremy, thank you very much indeed.
Thanks.
Right. We've moved on now a little bit, and we're looking at one of the other developments on the Nokia stand, their new imaging technology, the 808 phone. This has a huge number of pixels on the phone, and I just wanted to ask you a little bit about it. Can you tell me how many pixels it has got on the phone?
So the sensor is 41 megapixel sensor.
Yeah. And why has it got so many pixels on? What advantages does that give?
Well, we wanted to create high quality images, and now with this 41 megapixel enormous sensor size and with this peer view technology, we are able to produce high quality images for our users.
Yeah. Well, I must admit, I've seen some of the images, and they are absolutely amazing. You've been able to use oversampling and other techniques like that
Exactly.
to reduce the noise, increase the colour quality and the general quality. In fact, I saw one of the images projected onto the wall in your press conference earlier, and it was, I must admit, very good. But why have you done this on your old operating system?
Well, when we do something like this, it takes more than 1 year to develop it. So this cooperation with Windows wasn't started when we started to with this kind of technology.
So that's the reason why. But you'll be moving it forward into the new Lumia phones, I take it, in due course.
So we now have this technology, and of course we are going to use it in the future as well.
Right. Okay, thank you very much. We're here on the booth of the Small Cell Forum, which has recently changed its name from the Femto Forum. We've got Simon Saunders, the chairman of the Small Cell Forum now. I wonder, first of all, if you could tell us a little bit about the name change, why you've had to change your name from one to the other.
Thanks, Ian. Yes, I'd be very pleased to. So, as Femto Forum, we've been working on the enabling factors for femtocells in the marketplace for 5 years, and not wishing to blow our own trumpet too much, I think we've been successful at that.
Yeah, very much so.
Today there are 40 commercial deployments of femtocells around the world, and a further 13 or so announced commitments to launch services as well, many more in the pipeline. But there are now more 3G femtocells in the world than there are 3G macro cells.
And you see this growth going on from there?
I do, but from our point of view, that establishes a platform, and that market will continue to grow. We will continue to promote and support that. But what we've now recognised is there is so much more we can do with that underlying technology, and the industry is realising that, and that's powering this next move. And also, some people felt that femtocells was somehow narrowly defined. So I would talk about femtocells in the office, in the outdoor environment. But for some people, they want to talk about picocells or microcells or metrocells, all of which are very valid licensed spectrum small cell technologies. So we decided to change the name, A, because we wanted to avoid that market confusion, B, because we wanted to take the femto technology that had already been created and apply it as widely as possible, and C, because it actually reflected what we were already doing.
Right, yes.
We were already working on a number of areas in the technical and the market front on the wider usage of femto technology. People inside the Femto Forum knew very well that that's what we were doing, but we wanted to make sure that everybody else understood that if their interests were, for example, on LTE small cells deployed outdoors in busy metro areas, that our forum was a place to do business. And I must say that the response we've had to the name change has been outstanding. Everybody has seen it as an extremely logical move.
And one of the other things I just wanted to, I think you've said quite a bit about it anyway, but in terms of LTE, the new 4G technology, everybody's saying, well, yes, we need to get that in place. Where are small cells in that technology now? I think we both know the answer, but it would be certainly interesting to explore that a little bit more.
It's a very interesting question because we're in a kind of pivotal moment for LTE small cells. So in 3G, just to sort of set it in contrast, as it were, in 3G, clearly 3G networks had already been deployed in large scale before 3G femtocells came along. That was great, and continues to be great, because it provides that great coverage where 3G doesn't quite reach, it's addressing the high capacity needs and so on. The difference in LTE is that we managed to work with 3GPP to get small cell specifications in the specification from the very beginning. The release date specification that first created LTE included LTE, the key hooks for LTE femtos. Operators are now planning small cells into LTE from the beginning. An indicator of that was a study done recently, a survey of operators, suggesting 60% of operators saw small cells as more important to LTE networks than macro cells. Similarly, recently another survey has shown that when asked to rank the features of LTE Advanced in terms of business impact, small cells come away as far and away the winner in that. So it's all very well embedded. It's turned commercial. The first commercial deployment of LTE small cells was a couple of months ago by SK Telecom in Korea. And we've actually supported that directly in the forum. We created some interfaces between chips within LTE for femtocells and small cells generally, so that it was easy for access point providers to source those chips. And those interfaces are inside the deployments that SK Telecom has done. So we've had a direct commercial impact.
So we're seeing a really huge deployment of and use and incorporation of small cells now into LTE technology and all the other cellular technology.
Yeah, well, let me give you a sense of scale. So I mentioned we saw more 3G femtos than 3G macros last year. In the course of 2012, we believe we'll pass that milestone for all technologies combined. More femtocells than macro cells in the world. That growth is going to continue over the next few years. We're seeing approximately a 20 times growth over 5 years. And the outcome of that will be that by 2016, 88% of all base stations will be small cells.
That's absolutely amazing news. Thank you very much indeed, Simon, for all that insight and information. Really appreciate it.
You're very welcome. Nice talking to you.
Thank you.